Hello guys, my name is Tevulay. I am a student from Kazakhstan and today we'll discuss about data layers for web development and we'll compare three main types of these data layers. The first one is ORM and the second one is raw SQL, the third is NoSQL. So let's start. The main question that we will try to answer in this video is what to use and where to use. I mean by these questions, what exact type should we use and where it is most suitable to use. Before we start, I want to clarify what is ORM. ORM stands for Object Relational Mapping. It is a technique used in creating a bridge between object-oriented programs and the relational database. So on screen you can see some popular ORM tools for Java Hibernate, for Python Django, SQL Alchemy, for .NET Entity Framework, for PHP Laravel. There are many ORM tools and it's very popular. Now raw SQL. Raw SQL refers to the direct usage of SQL statements within a programming language or database environment without any abstraction layer or framework. When developers use raw SQL, they directly write SQL queries to interact with database, rather than relying on ORM tool or other abstraction layer provided by frameworks. NoSQL. The term NoSQL, short for not only SQL, refers to non-relational types of databases. NoSQL databases use non-tabular format to store data rather than in rule-based relational tables like relational databases. NoSQL databases use flexible schema model that supports a wide variety of unstructured data, such as documents, key value, white columns, graphs, and more. And also I listed some NoSQL databases that are commonly used: MongoDB, CouchDB, Oracle NoSQL database, and so on. Now let's dive into a comparison of these data layouts, since I gave some clarifications and definition of types. We will compare by some attributes. The first is the data handling approach. The second is complexity and the development time. The third is performance and optimization. The fourth is flexibility and the schema evaluation. The fifth is consistency and the transaction management. And the last one is use cases. The first one, data handling approach. ORMs abstract the database interactions by mapping database tables to objects in the application code. This simplifies data handling by allowing developers to work with familiar object-oriented paradigms. NoSQL involves writing SQL queries directly in the application code to interact with the database. This approach offers maximum control and flexibility over the queries executed, but it requires developers to manage SQL code directly. NoSQL databases provide a non-relational approach to data storage, often organized as key value pairs, documents, column families, or graphs, as I said before. They offer flexibility and schema design and are suitable for handling unstructured or semi-structured data. Complexity and development time. ORMs reduce the complexity of database interactions by providing high-level abstractions. Developers can work with objects and classes instead of dealing with SQL queries directly, which can accelerate development time, especially for CRUD operations. Using raw SQL gives developers full control over the database interactions, but requires writing and maintaining SQL queries. While this approach offers flexibility, it may increase development time due to query management. NoSQL database offers schema flexibility, which can simplify development of applications with evolving data requirements. However, designing an efficient data model and query patterns, NoSQL may require careful consideration, especially for complex use cases. And the performance and optimization. ORMs may introduce performance overhead due to abstraction layer between application code and the database. Inefficient queries generated by ORM can lead to suboptimal database performance, requiring optimization. Writing raw SQL Queries allow developers to optimize query performance by fine-tuning SQL code, indexing, and the query execution plans. This level of control can lead to more inefficient database operations. NoSQL databases offer high performance for certain use cases, such as real-time analytics or high-volume data investigation, due to their distributed and horizontally scalable architecture. However, performance optimization in NoSQL database may involve different techniques compared to traditional SQL database. Flexibility and the schema evaluation. ORM typically require predefined object relational mapping, which may limit flexibility in schema evaluation. Changes to the underlying database schema or object model may require corresponding updates to the ORM mappings. NoSQL allows developers to directly manipulate database schema and perform schema migrations as needed. This flexibility enables seamless schema evaluation without relying on the ORM or other abstraction. NoSQL databases excel in handling schema-less or semi-structured data, offering flexibility in schema design and evaluation. Applications with rapidly changing data models or requirements can benefit from the schema flexibility provided by NoSQL database. Consistency and transaction management. ORMs often rely on transaction management capabilities of the underlying database. In a SQL database, ORM can enforce asset properties through transactions. NoSQL. Transaction management in NoSQL follows the capabilities of the underlying database. Developers can explicitly manage transactions using SQL transaction commands, ensuring data consistency and integrity. NoSQL databases offer various consistency models, ranging from strong consistency to eventual consistency. Developers need to carefully select the appropriate consistency model based on the application's requirements and the trade-offs. Now the last attribute, use cases. ORMs are commonly used in web applications, enterprise software, and object-oriented programming environments, where developers prefer working with object-oriented paradigms. This simplifies data access and manipulation, especially for CRUD operations. NoSQL is suitable for applications requiring fine-grained control over database interactions, complex querying, or performance optimization. It's often used in scenarios where ORMs introduce overhead or cannot meet specific requirements. NoSQL databases are well suited for applications dealing with large volumes of unstructured or semi-structured data, real-time analytics, content management systems, and distributed architectures. They offer scalability and flexibility for handling diverse data types and use cases. Here on screen you can see the examples of using ORM tool and the NoSQL. The code is same but with different syntax. Now let's talk about the pros and the cons of these data layouts. The pros of ORM: productivity, portability, object-oriented mapping, CRUD operations. Cons: performance overhead, complexity, limited control. NoSQL's pros: maximum control, performance optimization, flexibility, schema management. Its cons: boilerplate code, SQL injection vulnerabilities, vendor lock-in. NoSQL pros: schema flexibility, scalability, high performance, and diverse data models. Its cons: consistency trade-offs, query limitations, tooling and ecosystem maturity, learning curve. So, in conclusion, the choice between ORM and the NoSQL and the NoSQL database depends on various factors such as development productivity, performance requirements, schema flexibility, and data modeling needs. Each approach has its own advantages and disadvantages. And understanding these trade-offs is crucial for selecting the most appropriate database solution for a given project. By weighting the pros and the cons discussed earlier, developers can make informed decisions and architect robust, efficient, and scalable database solutions tailored to their specific requirements. That's it. Thank you for your attention. If you liked the content, please click the like button and subscribe to my channel. Bye.